Hi, hello, welcome. We shall continue our discussion on static force analysis and we shall try to solve one more problem. The problem is already with you and a problem which has appeared in June-July 2013 question paper and it carries 14 marks. The problem goes like this, very simple single sentence. Refer to the figure. Determine the couple T2, sometimes they call it as couple, torque, moment, etc. all mean one and the same. Determine the couple T2 for the equilibrium of the system. So what is the system? System is a slider crank mechanism. So it has what is called as AB is 10 centimeters, BC is 70 centimeters and BD is 25 centimeters. Okay. So in addition, the magnitudes of the forces, P is 100 Newton and F is 300 Newton. Okay. So now a freehand diagram I have drawn here and this is what AB, BD and this is BC, this angle 60 degrees, this angle 45 degrees, this is what is P, this is what is F. So a freehand diagram, of course we need to draw the diagram to scale and later. Okay, so the mechanism is subjected to two forces. One force is on the piston on link number 4 and there is another force P which is 100 Newton on connecting rod. Okay, so therefore this kind of problem which there are so many ways of doing it, I shall demonstrate one way by dividing one single problem as I have shown here. This is single problem which I am going to divide it into two problems, problem number 1 and problem number 2. So what I have done is, in problem number 1, I have assumed that P is 0. You don't have P and you have only F and that problem I call it as problem number 1. And in problem number 2, I have taken F as 0 and only P has been considered and that has been written here. And if I add these two, and then find out what is called as the torque, let me call this as the T21, the torque required for the first problem. And similarly, let me find out what is called as the torque required for the second problem. If I independently do this and then add this, then I shall get what is called as the T2 which has been asked in this problem. T2 is the sum of T21 plus T22. Of course, the magnitude and directions also have to be taken into account when I add T21 plus T22. If this is clockwise, this is anti-clockwise, then one of them has to be taken as minus and then that is how I have to find it out. Okay, so now this problem I have written it like this and how did I write it, on what basis? This is what is using what is called as principle of superposition. Okay, so in this, coming to the application of principle of superposition, there are two forces P and F. Due to this, what is the value of T2 that has been asked? Okay, T2 is the effect of only P plus only F. This is nothing but principle of superposition. What is it? The effect of a number of forces. The effect of a number of forces is the sum of the effects of individual forces. This is what is called as the principle of superposition. And this method makes our analysis very simple. Okay? In the same manner as we did it in the previous case. Of course, there are other methods. We need not apply principle of superposition and P and F you can take directly and simultaneously and that also you can go ahead. That requires a little bit of understanding and depending upon your interest, if you approach me, if you want to know those methods, I'll be very happy to teach them also. So, but now, right now, this is the one which makes our method simple. Though it takes 5 minutes extra time, but you will not make any mistake. You will not have any opportunity to make mistake. Okay, as usual, the first step. What is the first step? What is the first step? Drawing what is called as configuration diagram. Drawing the configuration diagram. drawing the diagram, mechanism diagram to scale. Okay, so first you choose what is called as scale. Scale is equal to, first thing what you need to write, don't skip it. 1 centimeter is equal to 1 centimeter of the drawing. What you do, what does it represent? To decide this, you go through the values. AB is 10 centimeters, BC is 70 centimeters, and BD is 25 centimeters. Okay, so can I have a scale of, so if I take 1 centimeter of drawing is equal to 5 centimeter, then I need to draw BC 14 centimeter line. 14 centimeter, is it convenient? I think that is alright, 14 centimeter. Otherwise, you can take 1 centimeter is equal to 10 centimeter. I shall use it 1 centimeter equal to 5 centimeter. This is the scale I shall use it. Okay, so now again, the method I am not really drawing to the scale, I am just demonstrating the procedure. Okay, doesn't matter for me. So draw a line. So what is this line? This line is supposed to represent the line of stroke, and I am going to have piston this side, and therefore I have chosen a point, and this point is what is called as crank center. And you know that the angle made by the crank with the line of stroke, that is given as 60 degrees. You measure this 60 degrees, 60 degrees. Then draw a line. How much length line? AB is supposed to be 10 centimeters actually. So in our diagram, 10 centimeters divided by 5, 2 centimeters. I need to draw a line of length 2 centimeters. This is 2 centimeters. This is A and this is B. Okay, then BC, which is 70 centimeters, and according to our scale it is 14 centimeters. Okay, almost 7 times this. So it is a center, and probably it may come something like this. So you have what is called as, this is the point C. It be a center, and BC 14 centimeter as radius. You draw an arc. Okay, this is. Okay, then at C you draw a rectangle like this, which is supposed to represent what is called as piston. Remember, it is circular. Okay. Then at B also you draw a small circle to represent what is called as the turning peg. Then you mark point D. BD is 25. According to scale, 25 divided by 5 centimeters. From B you measure 5 centimeters, and probably this is the point D. Okay. This is where you have the force P. Okay. Then represent the forces. So on link number 4, piston, you have what is called as the force F. Force F, which is equal to 300 Newton. Then at D, you measure 45 degrees because it is given, and draw a line, and you have a force in this direction. That value is equal to P, which is equal to 100 Newton. So this is what we call it as the configuration diagram, the first step. Okay, draw this. Then after this, now we are going to solve this problem as if once you assume P equal to 0, and next time you assume F equal to 0. So I have already written here, this is the first problem and this is the second problem. I shall solve first problem now. In first problem, P is 0. So assume. So what we are doing now is assume P equal to 0, as if P you don't have. Okay, with respect to the method what I described, I want to reduce time now, reduce the time of my solution, and therefore while drawing, the next step is to draw what is called as free body diagram. So free body diagram I shall not draw in the order link 2, link 3, link 4, link 5 like that. Okay, I shall spend some time. Assuming P equal to 0, probably I can refer to this diagram. And I shall also name this. Say this is link number 2, this is link 3, and this is link number 4. Why to number? So this will help me to decide what is the notation of the force. F(I)J, what is I, what is J, that will help me. Okay, though it is not mentioned in the problem which is link 2, which is link 3, you name them in your convenient way, and then accordingly we are going to represent the forces. Okay, so this is 2, this is 3, this is 4, and this is link number 1. Okay, fixed link. Okay, so now I am assuming P equal to 0. So I want to draw what is called as free body diagram. Okay, so here I shall choose a link. The first free body diagram which I am going to choose shall have only 2 force system. Okay, so now, so this link number 2, I know that it is going to be subjected to a torque T2. This is what I have been asked to find it out. And at A and B there are 2 forces, therefore link number 2 is not a 2-force system. And coming to link number 3 with this assumption, assuming P equal to 0, P is 0, in that case link number 3 is a 2-force system. That is nothing but this problem what I am solving. Link number 3 is a 2-force system, and therefore I shall draw the free body diagram of link number 3 first. So before I proceed that, I shall measure this angle as I did it in the previous case. This diagram you actually have drawn it, you know it, and therefore alpha value also you know. Okay, so therefore you choose any point, you draw a horizontal line, and then you measure alpha, and then draw what is called as the link number 3. This is link number 3. And this is C, and this is your B. And as you know that, of course, you have to draw the same length, and I have my demonstration purpose. Since I don't have space, I have drawn a smaller one. But you will be drawing the same length. The length will be same. And at B and at C, you are going to have 2 forces. And I know that it is a 2-force system. And the 2 forces must be equal, opposite, and collinear. And therefore, this force, what is this force? This force at C is from link number 4. Therefore, this is F4, 3. And what is this force? This is F2, 3. At this point B, we have a force. Okay, so I hope you will be able to see in a better way. And this force, this is F4, 3, this is F2, 3. Okay, so now I know what is the direct line of action of F3, 4, and I also know what is the line of action of F3, 4. Okay, so now I shall draw the free body diagram of link number 4. Why? Because I know the value of F, I can make use of this, draw force triangle, and find out the value of the unknown forces. Therefore, I shall draw the free body diagram of what is called as link number 4. So this is the pin where I have the connection with link number 3. Okay, so at this center of the pin, I have a force. What is this? This line is parallel to the connecting rod. This angle is, what is this? This angle is alpha. And what is this force? This force is due to what? Due to link number 3. Acting on what? Acting on link number 4. Then I also have what is called as the force F, which has been given as 300 Newton. This is 300 Newton. Okay, 300 Newton, F3, 4. Then this link 4 is also connected with link 1. You have isolated it from 1, and it is a sliding pair. And whenever you have sliding pair, the force will be perpendicular to the contact surface, and therefore the third force is like this. This is F due to 1 acting on link number 4, F1, 4. Okay, this is the free body diagram of link number 4. And instead of, before you go to link number 2 free body diagram, let me complete its analysis. So what is this? Link number 4 is a 3-force member. So which are the three forces? F3 4, F1 4 and F. Okay. So now, so out of these three forces, one is known and all the three have a common point. All of them are passing to the center of this pin. And the resultant force must be 0. Okay, very simple. Then now choose, decide to draw what is called as force polygon. Say 1 centimeter is equal to 50 Newton. 50 Newton. So choose a point, draw F 300 Newton. 300 divided by 50, 6 centimeters. Draw 6 centimeters line. Okay, this is what is called as 300 Newton. Now at this point you can draw now any one of the two forces. I shall draw F14. How much length? I don't know. The magnitude. And why upwards? I don't know. I can draw it downwards also. Okay, upwards or downwards. You can call this as O and you can call this as A or O1, A1. Okay, so then at the tip of the second force, where is it? That I don't know. I am supposed to draw the third force. So I don't know the tip of the second force, but I know where the third force must end. Since the resultant has to be 0 and the third force must end at this point. The third force must end at this point, and therefore at this point you measure what is called as alpha and draw a line. And therefore the force triangle is complete. So now you can come back and fix the direction. This is 300 Newton. This is what? This is F14, which is in the upward direction. And what is this force? This is F34, which you can call it as this point B1. Then measure the length B10. Okay, B10 in centimeters. Multiply it by scale. Scale is what? 50. That is equal to so many newtons. What is this force? This force is F34. On the same lines you can find out F14 also. What is the direction of F34? From this triangle you go back here and put the direction. F14 upwards. So once you know F34, what do you know? You know F43. F34 and F43, they are equal and opposite. If you know F43, what do you know? You know F23. The magnitude of F43 is same as F34, which is same as F23, the same as F32 also. Okay, so now I have to continue with the free body diagram of thing number 2. So this is point A. You draw a horizontal line, measure 60 degrees and draw 2 centimeters. Not 2 centimeter wide, because I want to represent 10 centimeters to that scale. So this is A, this is B, this point is B. Okay, at B, it is connected to link number 3. Therefore, there is a force from 3 acting on 2. That force, I call it as force from 3 acting on 2. But I know the magnitude and also direction F23 is same as F32, which is according to the connecting rod, along the connecting rod and extend it if you require. Right. And what is the direction? F23 direction is this way, and therefore F32 direction is this way. So if you know F32, at point A I have force F12, which are parallel, because this is a member which is subjected to 2 forces and 1 torque. 2 forces and 1 torque. The 2 forces must be equal, opposite and parallel. Therefore, at this point draw a line parallel to this. So what is the direction of this? It is this way. And what is this force? This is F12. Then find out what is the perpendicular distance between the two. This is what I call it as X. F32 and F12 will form a couple. What direction couple? Couple is anti-clockwise direction. Therefore, this is what is called as T21. This is only the first problem. So find out T21, which is equal to F32 multiplied multiplied by x, so many centimeters, multiplied by the scale of the diagram, that is 50, now 5 centimeters. So you do this you get so many Newton centimeters, because this is in centimeters, this is in Newton, and you get what is called as so many Newton centimeters. So this is what is. Or you can also write down now so many Newton centimeters. Is it clockwise or anti-clockwise? This is clockwise. Okay, this is the first part of the problem. Now the second part, what is that? Now F is equal to 0. The force F is equal to 0 and F is 0. Now P is 300 Newton. P is 100 Newton. Okay, so now go through all this. That is nothing but this diagram. So which link is having only two forces? So link 2 is not having, it is a torque and two forces. Link 3, it is having two forces, one at B, one at C. In addition to this, you also have a force P which is at point D. Therefore, it is a 3-force system. Now coming to link number 4, I don't have F. Therefore, link number 4 is subjected to only 2-force system. What is that? Link number 4. So the free body diagram of link number 4 I shall start with. Link number 4. So what are the two forces? This link number 4 has been isolated from link number 3 and link number 1. So I have what is called as F14 and I have what is called as F34. These are the two forces. Okay, so out of this, I don't have any idea about the line of action of F34 because I have not drawn the free body diagram of link number 3. But I know the line of action of F14. How is it? It has to be perpendicular to the contact surface. Therefore, it has to be like this. This is what is F14. And I know that this is subjected to link 4 is subjected to only two forces. Therefore, the two force, the other force, what is that other force? Other force F34 also must be along this line. This is the line of action of F34 and this is the line of action of F14. Okay, now with this information, now I shall draw the free body diagram of link number 3. Okay, at this point, this is your C. Draw a horizontal line, measure an angle alpha and draw a line. Okay, to represent 70 centimeters, 70 divided by 5 or 14 centimeter. This point is what is B. And at B, what do you have? Okay, sorry, at C. At C, what do you have? You have what is called as F43. This is link number 3. At C, this link has been isolated from link number 4 and F43. I have what is called as F43 at point C. And what do I have at point B? At point B, I have what is called as F23. So F43 is the same as F34. The line of action F43 and F34, they are having the same line of action. This is what is the line of action of F43. And what is the line of action of F23? That I don't know. And in addition, I also have what is called as a point D. At point D, I have one more force. What is that force? What is called as P. So you measure 45 degrees. This is 45 degrees. And you have a force. What is called as P. P is 100 Newton. That also I know. Okay. So now this force F23. Right now, let me show it as if I don't know the magnitude. I don't know the direction. But I know that this force will pass through point B. Okay, so now go back to our earlier discussion. What is that? What is this system? So this is a link 3 which is subjected to 1 force, 2 force, 3. The 3 forces, I don't have any torque on anything. So 3 forces system. If at all it has to remain in equilibrium state, the 3 forces must have a common point. That's the first part of the condition. 3 forces must have a common point. So this is the line of action of one force. this is the line of action of the second force, the third one I don't know. So therefore, since I know the line of action of two forces, let me find out what is the common point of the two forces. I just extend it and I just extend this. This is the common point of P and F43. And this must be the common point of the force F23 also. What is the meaning of that? F23 has to pass through this point B and it also must pass through this point because this is the common point of F23 also. Therefore, join this point and this point. What does it indicate? And extend it. And what does it indicate? It indicates the line of action of F23. Okay? F23 line of action is known. P is known completely. And F43 line of action is known. And therefore, now what we do? We draw what is called as the force polygon. 1 centimeter is equal to, this is 100 Newton. Therefore, I shall choose say 50 Newton. 1 centimeter is equal to 50 Newton. Okay, I shall choose a point and let me call it as say O2. O2. The one which you know, please draw that first. What is that? 100 Newton I know. 100 Newton, where is it? You draw the horizontal line, measure 45 degrees and draw a line, how much length line? Okay, 100 and scale 50. So draw this, what is called as 2 centimeter line and let me call this as say A2. Okay, now you draw any other force, the second force. Let me draw F43. F43, okay, I think I need to make some more space here. Okay, I shall rub this. The scale will remain same, no change. Okay, because I need to draw a line. Okay, the next force. This is the tip of the first force. At the tip of the first force, draw the second force. What is that second force? I am taking it as F43. F43, I know that it is vertical. I know that it is vertical. Okay. So I don't know whether it is upwards or downwards. You draw a line of indefinite length. Okay. Now the third force, at the tip of the second force, you draw the third force. I don't know this tip. But I know that the resultant must be 0 and therefore at this point the third force must end. And this is the line of action of the third force. Probably you can measure what is the angle here and you need to draw a line parallel to this at this point and draw a line which is something like this. This line is parallel to this. Please remember, this line is parallel to this. Okay, so now the triangle is ready. This is your O2, this is your A2, probably this is your B2. This is your B2. Okay, so now I come back and mark the directions. This is your O2, this is your A2, first force. Then A2, B2 is your second force. Then B2, O2 is your third force. And what is A2, B2? A2, B2 downwards, which is this force. What is that? That is nothing but F43. And what is this force? What is this? B2O2. B2O2 is nothing but your F23. F23. So what is the direction of F23? It is from B2. So therefore, this is the direction of F23. So once you know the direction of F23, you know what is F32, right? So once you know F32, so if should I make some space here and then complete? Okay, draw the free body diagram. This is your A, this is your B. Okay, so this is the torque T2, which I need to find out T2 second, T2 2. So F23 is towards left. And therefore F32 is towards right. This is your F32. And draw a line parallel to this at point A. You get what is called as? What is this force? This force is F12. And what is the direction? Exactly opposite to this. This is the direction. Find the perpendicular distance between the two. This distance I call it as x2. Then you know what is this? This is f32. f32, you know the magnitude. How do you find it out? You know f23. f23, measure this b2, o2 multiplied by scale, multiplied by the scale of this force polygon. All that will give you what is this f23, and the same thing f32, the same thing f12, you know x2, f32 multiplied by x2 will give you the torque. This f32 and f12, they form clockwise moment. And if your T22 also is clockwise, then it will not remain in equilibrium state. Therefore, T22 must be exactly opposite to this. Therefore, you know what is T22? T22 is anti-clockwise. T22 is anti-clockwise. And what is T21? T21 is clockwise. Check what is more, whether this is more or this is more. If this is more, then the resultant is the difference between the two and clockwise resultant. If this is more, then this minus this, the resultant is anti-clockwise. So you add the two to get what is called as T2. Okay? So I don't have space. I hope, I'm sure you have understood it and you'll be able to complete it. Okay? Thank you. Good day. Practice this. I shall definitely have these kind of problems in the test also. Go ahead.